right, so before we get into this, I want you to go and make sure you watched the Mythbusters YouTube video. It's just a couple minutes long, but the first lesson here is based off of that. So go watch that first and then come back here. All right, so this video is going to walk you through the week 5 Google Doc, the first part at least. This week, your assignments that are due are the week 5 Google Doc, and then also on AP Classroom, parts C and D for the multiple choice review. All right, we're going to go ahead and get started with part 1. Okay, so in that video, which hopefully you watched, Mythbusters investigated the question about whether yawning is actually contagious. So here's a brief recap. Each subject was placed in a booth for an extended period of time, monitored by a camera. 34 subjects were given a yawn seed by one of the experimenters. That is, the experimenter yawned in the subject's presence before leaving them. The remaining 16 subjects were given no yawn seed. So, drawing an outline of this experiment, we haven't outlined experiments for quite some time, but basically, just gonna kind of outline what happened. So we start with 50 subjects, and it's totally fine to bullet point this out. Randomly assigned to group 1, which had 34 people, or group 2, which had 16. Group 1 receives the yawn seed. Group 2 gets no yawn seed. And then the last part of the experiment is to compare proportion of yawners. All right, so the next part is just asking you to sort of analyze this. So I want you to figure out, okay, so if P1, P sub 1, is the true proportion of yes yawn seed people who do yawn, what is P hat sub 1? So that's going to be based off of our sample. So basically, based off of our sample, what's the proportion of people who got the yawn seed and who yawned? And we're going to compare that to P hat sub 2, which is going to be the proportion of people who got the yawn seed who... Oh, yeah, there's a typo here. Weird. Okay. This should say no. I'm going to go fix that in your Google Doc. I was going to say those are literally the same thing. So P2 is the proportion of no yawn seed people who yawn. And then I want you to find the difference. Hit pause and go, and then play when you're ready to go over those. All right. So the proportion for P hat sub 1 is going to be how many people yawned out of the people who got the yawn seed. So I'm going to look for 10 out of 34, which is 0.29. Then for B, it's the proportion of the no yawn seed people who yawned. So that's going to be 4 out of 16, which is 0.25. The difference here is 0.29 minus 0.25, which is 0.04. I want you to try to answer questions 3 and 4, and then we'll go over those when you're ready. All right, so for question 3, do the data provide some evidence that yawning is contagious? Yeah. The people who got the yawn seed yawned more often. Yawn seed people yawned more often. And keyword here is some evidence. Like, it may or may not be convincing for you, but is there some evidence? Like, yes, we have some evidence. All right, for question 4, this is an opinion question. The hosts of Mythbusters used this information to conclude that yawning is contagious. Do you agree? You could go either way on this. You could either say yes, there is a difference in yawning. And some of you might have gone down that route. Or you might have said, no, 0.04 is a pretty small difference. So either way there is fine, whatever you feel. If you're going with this one, you could say, and could have happened by chance. Also, probably some of you noticed the sample sizes were fairly small. All right, question 5. Yet again, we're going to pretend to do an activity since people are going to be doing this at different times and in different places, and I'm recording this like a month before you're going to actually do it. Yeah, okay. So your class will pretend to investigate whether the results of the experiment are statistically significant or if they could have occurred purely by chance due to random assignment. Okay, so we're going to first write out our null hypothesis here before we jump into our fake experiment. Okay, so our null hypothesis, I'm going to write that as H sub 0, is that the proportions are the same. The way that I write that is either like this, the difference is 0, or I could write it as P1 equals P2. Both are fine ways to write that. So our null hypothesis is that yawning is contagious. Sorry, not. Yawning is not contagious. I know the problem doesn't ask us for the alternative hypothesis, but I can go ahead and write that in anyway. You don't have to, but just to be clear with it. Our null hypothesis, I want to make sure I'm getting my 1s and 2s right. So 1 is the yes yawn seed people. My null hypothesis would be that if I subtract the yes yawn seed minus the no yawn seed, that's going to be greater than 0. And that would be that yawning is contagious. So again, that was just like a little extra, but I just wanted to go over that just because usually we write out both hypotheses. All right, so jumping in my Google Doc. Okay, so pretend this, okay? Sit back. If we were in school all together, I would give each group 50 cards. The 50 people in the experiment would be represented by the cards. A person on the card is either a yawner or a non-yawner, no matter which treatment they're going to be randomly assigned to. So we're kind of going as if the null hypothesis is true. So then every group would shuffle the 50 cards and put them into 2 piles. One group of 34 that gets the yawn seed, and one group of 16 that does not get the yawn seed. And then you would record the proportion of people who yawned in each group, and you would do it 3 times. On your doc, you can see an example of what your results might look like if you did this. And also, if we made a class dot plot, what that might look like too. Sorry, this is all pretend. I wish it could be all real. But just to make sure this experiment the simulation is clear, we are just randomly shuffling our yawners versus non-yawners into the 2 groups because we are assuming the null hypothesis is true. For the test, we're going to assume that yawning is not contagious. So then it wouldn't matter which group people were in. Okay, for question 6, in what percent of the class's trials did the difference in proportions equal or exceed 4%? That was what Mythbusters got in their experiment. So let's look at our fake data here. The ones that would be 0.4 or more extreme. So with this, we're always looking for like the value that, like our proportion or our sample value, or something more extreme than that. So either a difference of 0.4 or greater. I want you to try to figure out what percentage is this out of the total trials. And then I want you to try question 7 as well. So try 6 and 7, and when you're ready, you know what to do. All right, so for question 6, when we're looking at how many there are 12 that are 0.4 or greater, 0.04 or greater, out of 30 total, which is 40%. So that's a really large proportion, actually. So let's go ahead and try to conclude based off of that. So because 0.40 is greater than 0.05, we fail to reject the null hypothesis. And do not have convincing evidence that yawning is contagious. So basically, the Mythbusters did not use good statistical practices to determine their conclusions. Shame on them. They act all sciencey and stuff, but then look. All right, so we're going to go ahead and go over some notes here. Great, so we're going to look at hypotheses. So first of all, we can put a title on this. We're looking at tests about a difference in proportions. And that's what we were looking at here with yawners versus, or people who got the yawn seed versus not. Okay, so first thing would be our hypotheses. So when we're looking at a difference in proportions, our null hypothesis is always going to be that there is no difference. And we can write that either one of two ways. I can either write it as when I subtract them, I get 0, or I can write it as they are equal to each other. Both of those are fine. Doesn't matter which. There are 3 different alternative hypotheses that you can pick from depending on the situation. All right, so one of them is that if you do P1 minus P2, you get a result that is less than 0. Another one is if I subtract those, I can get something greater than 0. Or if you are looking for a double-sided, it's just going to be that it's not equal to 0. And then just for what the other way you can write those, I can write P sub 1 is less than P sub 2. This would be P sub 1 is greater than P sub 2. And this would just be that they are not equal to each other. All right, so a couple things to check when you're conducting tests about a difference in proportions. Just need to insert another slide. And these should look familiar. It's the same conditions we've been working with for a while, but there's just a couple things to keep in mind here. So we have to check for random samples or assignment. And basically random samples would allow you to generalize. Random assignment allows you to show causation. But if you don't have either of those, then you can't really do anything with your results. All right, second one is our 10% condition. You only need to check this if you're sampling without replacement. And then just a reminder on what this means. If we have 2 different proportions we're looking at, we are going to have to check for both of our samples. So I'm going to check that my first sample is less than or equal to 1/10 of my first population. Lowercase n is your sample size. Capital N is population size. Okay, and then we also have to check that for our second one. Our first sample has to be less than or equal to 1/10 of our second sample. And then the last thing we have to check for is large counts. And here it's a little bit different. When you're looking at 2 different proportions, we have to first figure out what's the combined p hat. So I'm going to switch colors here just because it's getting a little crowded. I'm going to write that as p hat c, and that stands for combined. So to do that, you are going to figure out the combined proportions like if you're combining both of your samples together. So I'll show you what this looks like in a bit. But basically you're just gonna like lump everyone together. Once you do that, we have to check for large counts based off of this. So I'm gonna take my first sample, multiply it by that combined probability, or not probability, proportion. I have to make sure that's greater than or equal to 10. I have to take my first, just wishing I would have left more space for myself. It's okay. I have to take my first sample and multiply by 1 minus the combined proportion. Make sure that's greater than or equal to 10. And then same thing for my second sample size. So I'm going to do all of this for n sub 2. Make sure that's more than equal to 10. And then p hat combined greater than or equal to 10. So you have to check all of those. The thing that's different with this specific situation where we're talking about a difference in proportion is just that we have to find our combined proportion for p hat. All right, so I would like for you to try the check for understanding. When you're ready, you can hit play and we'll walk through it. But as always, I know I say this all the time, but I do want you to try it on your own first so you can actually like take some ownership over this. And if you get stuck or get confused, like that's fine. It's all good. Hopefully we'll clear it up together or when you hit play, but please try it. Okay. So I'm gonna write out a couple of things here that'll help us figure out how to answer the stuff in here. P hat for my first population, and that's yes, Jan seed people. We figured this out earlier, but just to have it here as well, it's 10 out of 34, which is 0.29. P hat sub 2, which is my no Jan seed people, was 4 out of 16, which is 0.25. For the combined p hat, basically I'm going to take the 10 and the 4, those are my numerator, and the 34 and the 16, those become my denominator. That's 14 out of 50, which is 0.28. So that's what I'm going to be using to check conditions. Okay, so the parameter here basically is what we're trying to find. It's P1 minus P2, which is the true difference in proportions of people who would yawn. And then I'm going to say the direction as well. We're going to be doing yawn seed minus no yawn seed. It's important to say that because otherwise like you might get like a backwards answer. So like whichever way you're going to subtract, you should label that. Our statistic, we have that, it's 0.04. It's p hat sub 1 minus p hat sub 2, which is 0.29 minus 0.25, which is 0.04. All right, our hypotheses, we had these from earlier, but just so that they're all in one place. H sub 0 is that P1 minus P2 is equal to 0. And what that means is that yawning is not contagious. Your null hypothesis is always like the most boring possible thing. Your alternative hypothesis is like what you're suspecting or what you're kind of trying to test for. Here, that would be that P1 minus P2 is greater than 0. If that's the case, that would show us that yawning is contagious. And then our significance level, it doesn't tell us, but whenever it doesn't say, just go with 0.05. That's definitely the most common significance level. It's just sort of like we can assume that's the significance level we're going with, even if it doesn't tell you. Okay, then we have to plan this. So the name of the procedure, we haven't done this one yet, so this is new. The 2-sample z-test, I don't think we've done it, for P1 minus P sub 2. And then checking conditions, this is just what we went over in the notes. So random, we have random assignment, which means we can show causation. We didn't have random sampling. It was just the people who were in the study. So we are not going to be able to generalize, but at least we can show causation. Okay, for the 10% condition, we're not sampling without replacement. So we don't actually have to check. And then last part, the large counts. Okay, so there's a few different things we have to show here. I'm gonna take my first sample size and multiply that by my combined proportion, which was 0.28. That's what we got over here. I'm also gonna take my first sample size and multiply by 0.72. These numbers, they just add up to 1. So to get the 0.72, I did 1 minus 0.28. Okay, so I'm getting 9.5 there and 24.5. So, interesting. Let's see what happens with the other one. If I've got 16 and 16, it's going to be the same stuff, 0.28 and 0.72. And we're looking to see whether or not these are greater than or equal to 10. This one is, but these two aren't. So if you're doing an FRQ or something and this happens, you can still conduct the significance test, but when you conclude, you should mention something about how, because the large counts condition wasn't met, we need to be cautious about our results. So you don't have to be like, well, too bad, can't do it. Probably should still do it, but just mention the fact that large counts condition wasn't met. All right, that's it for part 1.